Law number one states that an object in motion will stay in motion and an object in rest will stay at rest unless acted by an unbalanced force. A good example to show this law will be throwing an object. Let's say this wallet. If we throw this wallet, as you will now see, it will stop. Why did it stop? Well, this is because it was acted by an unbalanced force. In this case, the unbalanced force was gravity. If there was no unbalanced force at the field where I threw the object, it will maintain its velocity forever. This will mean that it will never stop. The ability of an object to maintain its movement is called inertia. So, if the movement is 100, it will stay at 100. And if the movement is 0, which means that the object is at rest, it will stay at 0. Force equals mass times acceleration. People think that this law doesn't really make sense, but I will show you with an example why it is so important. Okay, so a group of scientists want to know which of the two objects, in this case a tape and a cell phone, is going to impact harder on the floor when released from a third floor of the building. So after calculating the weight of both objects, they realized the tape is 1 kilogram and the cell phone is 2 kilograms. So they can rely on the second law of Newton to solve this problem. First of all, you have to know that force equals mass times acceleration. So based on this formula, we can solve the problem. Knowing that the acceleration of gravity is always 9.8 meters per second squared, we can know that we can solve a problem for each one. So mass, in this case, will be 9.8 times 1 kilogram will equal 9.8 newtons. And this one, for the soft one, will be 9.8 times 2 kilograms, which will be 19.6 newtons. So after solving this problem, we can know that the cell phone is going to impact even 2 times harder, even more than 2 times harder than the tape when it is released from the third floor of the building. This law can work for everything, from small objects to big objects such as rockets and space stations. For every action, there's an equal and opposite reaction. As all Newton laws, this law is around us every day. It explains things such as why I'm standing right now on the floor and not falling through it. An example would be why this golf ball remains on my hand. This golf ball, because of its weight, creates a downward force. My hand simultaneously is creating an opposite and equal force. In this case, upward. These forces always have the same magnitude but opposite direction. This is known as action and reaction. This is why the golf ball remains on the same place.